in the spirit of building intuition, let's just see one quick example of this. If I have rho being a pure state, the zero state, let's calculate the x, y, and z coordinates to see that it indeed matches what we expect. So what should they be? The x coordinate should be 0, the y coordinate should be 0, and the z coordinate should be positive 1, right, based on our diagram. Let's just make sure that that's true. So using this, I would calculate the x coordinate as trace of rho x always, and that's the trace of rho, let me substitute rho, 0, 0, poly x. Now I use my formula for transforming the trace to an expectation value, 0x, 0, or you could just evaluate it like this. But from this, it's easy to see x applied to the 0 state as the 1 state, so that's orthogonal to 0, so this is 0. Similar thing with y, trace of rho y, trace of 0, 0, poly y, 0, y, 0. Now in this case, y you can always think of as the combination of a bit flip and a phase flip. So the phase flip part of the 0 state will do nothing. The bit flip part will change 0 to a 1. So that will again be orthogonal. And then the last thing, last coordinate, trace of rho z using the definition, trace of 0, 0, poly z. Now in this case, z acting on the 0 state does nothing. So I get the 0 state again. 0, inner product 0 is 1. So that's indeed the coordinates that we expect. The next example you might want to try is rho being the 1 state. So that's at the south pole of the Bloch sphere. So that should have a z coordinate of -1, right? And the x and y should be 0. And you could follow the same reasoning to see that that's true. For the z coordinate, z acting on 1 will give you the -1 state. And so that'll give you the -1 here.